Hello, everyone. My name is Sierra,
My name is Isaiah.
My name is Cesar.
and we'll be going over the locomotion of marine animals. So, what is locomotion? Locomotion is just a fancy word for the way an animal moves around. This can include things like walking, running, swimming, or flying. When an animal moves, its muscles, bones, and joints all work together to make it happen. Locomotion is important for marine animals like fish and whales because they need locomotion to help them swim and move around in the water. Swimming helps them find food, avoid predators, and migrate to different areas. Some marine animals, like sea turtles and seals, also use locomotion to move up on land and lay eggs or take care of their young. Without the ability to move through water, marine animals would have a hard time surviving in their habitats. So today we'll be talking about fish adaptations, and marine mammals. These marine animals all have unique ways of moving through water. So fins on fish are specialized appendages found on the body of fish and other marine animals that are used for movement and control in the water. There are several different types of fins, each with their own unique purpose. So first, the dorsal fin. This fin is located on the back of the fish. This helps maintain stability and balance while swimming. So, a fun fact about sharks is that they also can use their dorsal fin to make sharp turns. Next, we have the pectoral fin. This fin is located on the side of the fish, just right behind the gills. This helps for steering, braking, and hovering in place. So, a fun fact is that the pectoral fins are super important for fish that swim slowly or also swim in tight spots like coral reefs. Lastly, we have the caudal fin. This is going to be on the tail of the fish. This helps with propulsion and forward movement using a sweeping motion. The size and shape can change depending on the type of fish. So, a forked tail allows for quick and easy movements. Others have a broad, flat tail that creates thrust for powerful swimming. So next, we're going to be talking about fish adaptations.
So, fish adaptations. So, there are many different types of fish that have the most fascinating adaptations and techniques for moving through the water. So, for example, we have anglerfish. So, anglerfish live in the deep ocean and they live really close to the seafloor. It is really dark down there. So anglerfish use bioluminescent lures in order to attract prey. They move and hover in the water by relying on their long dorsal fins. Next up, we have seahorses. So seahorses are a very unique type of fish with a specialized body shape that are adapted for slow, gentle swimming. Using the dorsal fin on their back, as shown right here, they use these to move through the water, and they use the pectoral fins to help steer and hold position. Next up, we have eels. So eels have a long snake-like body shape. They have to move through the water using the S-shaped undulating motion. They have to actively swim to maintain their position in a water column. Next up, we have flying fishes. So flying fishes use their caudal fins to generate thrust and lift to move. They also move their caudal fins left and right really fast in order for them to shoot up out of the water. Then they use their wing-like pectoral fins to glide above the surface. Next up, we have apulent sharks. So these sharks have fins that are modified into leg-like structures that are flexible and strong enough to support their body weight. They also use their fins to move through the shallow pools during low tide. Next, Cesar will be talking to you about marine mammal locomotion.
So we're going to be focusing on two main groups of marine mammals. So first we have our cetaceans, which are our whales, dolphins, and porpoises, and our pinnipeds, which are our seals, sea lions, and walruses. So these marine mammals, they spend the entirety of their lives in the water, and so they have to be very efficient swimmers. And so marine mammals will swim with an up and down motion as opposed to a side to side motion in fish. And with that motion, compared with their strong musculature, they use that to propel themselves forward. So dolphins are capable of reaching speeds of up to 35 miles per hour, and whales are capable of making long migrations spanning thousands of miles. So many marine mammals are also very capable divers. So animals such as the sperm whale are capable of diving at depths of up to 7,000 feet, and they can hold their breath for up to an hour and a half. Now, one unique form of locomotion that is particularly unique to dolphins is what is known as porpoising, and I have a video demonstrating that here. So the reason behind this is dolphins essentially use this technique to help conserve energy. So dolphins, of course, need to breathe air, but the issue with that is traveling for extended distances just underneath the surface is very hard for them to gain momentum and propel themselves forward properly. So instead, what they'll do is they will swim at about 5 to 10 feet below the surface and essentially just jump out of the water to take a breath, and they'll go back down and use that momentum to come back up and to take another breath. And so by doing this, they actually help to conserve uh, energy when coming up for breath. And so some other adaptations include blubber, which is especially useful for energy storage, insulation, as well as buoyancy. They do have a streamlined shape, so they are very hydrodynamic and can propel through the water very well. And so, of course, our flippers and our pinnipeds and our flukes on the tails of our cetaceans also very much help them move through the water very efficiently. So now we're going to do a bit of true or false. So our first statement is caudal fins help with propulsion and forward movement. If you guess true, then that would be correct. Our next statement is dolphins are capable of swimming at speeds up to 65 miles per hour. This statement would be false, as dolphins are only capable of reaching speeds of about 35 miles per hour. Our final statement is eels swim in a straight line. This would be a false statement since eels swim in an undulating motion in more of an S shape. Thank you for watching. If you have any questions, please leave them in the comments below.